Hey guys, now we're going to be learning how to solve some quadratic inequalities. So they're not just simple equations, they're going to be inequalities, so you have to take some extra care when you're solving these questions. Now, here I've got two different scenarios for you, and I've just drawn up a simple parabola. You know, our quadratic, when we draw it up, it's going to look like a parabola, isn't it? Now, these are just two basic parabolas, and as you can see, I've put down the x-intercepts, so the intercepts are a and b. For both of them, they're exactly the same. Now, again, in this section, guys, where your x-intercepts are is very, very important because we're usually solving for where x is. So make sure you can quickly identify what the x-intercepts are as you, before you do anything else. Now, the only difference is that for the first diagram, we're looking at above the x-axis. So see how I've colored that in yellow? That part, which is above the x-axis. Now the x-axis is where y is 0, isn't it? So we want to know when y is greater than 0. So that part. Now if I want to express that in terms of an inequality, then I can put my solutions like this as I have over here. So because we're solving for x, this part here, the x values that represent this part of the graph are all of these ones. So all of these ones on the left hand side of the point A. So it's going to be x is less than a. Now this part, this yellow part for the x values that represent this yellow part are all of these ones, isn't it? All of these ones on the right of b. Now if it's going to the right, it's greater than b. So we can say that x is greater than b. Now, depending on the question, you have to identify whether it's going to be including these points or not. So if they have something like greater than or equal to, or in other cases they might use less than or equal to, if they have that extra bar there, make sure you also include your bars here. So make sure you carefully take note on what the question asks you to do. So that's something you might want to consider. So that is it, guys. That's for the first part where the y is greater than 0, above the x-axis. Now, this part, the yellow part is under the x-axis, so this is where y is less than 0. Now this part, again, we're going to be solving for x. So all the x values that represent this yellow part of the graph are these parts, these values, all of these ones which is in between a and b. These x values, isn't it? So these values are greater than a but less than b, so this is how we write it. X is greater than a but less than b. Again, you might need to put bars here if the question says including the points. So you have to, again, take some special consideration there. And that is, guys, so that's it. So what you're going to know is where y is greater than 0 or whether y is less than 0. Those are two things you want to consider. If it's greater than, we have two separate answers. And if it's less than, we have one group solution because it's in between two values. Alright guys, so let's try the questions. Starting with question 1, it says solve y equals to x squared minus 2x minus 3. So that's the y, but we want to know for the values for x. So when it's asking you to solve, we're basically solving for the x values here, where it's greater than 0, where y is greater than 0. So greater than 0, guys, means it's above the x-axis, isn't it? Now, before we actually do this question, even if the question doesn't ask for you to sketch the graph, I want everyone to be able to sketch the graph in order to do this question. So if you draw a graph, you won't make any silly mistakes at all. I guarantee you. So guys, the first thing I'm going to be doing is drawing our sketch of the parabola. Now, as I said in the previous part of the introduction, the most important things are the x-intercepts. Right? So don't worry too much on drawing a perfect graph, just make it really brief, but as long as you have the correct intercepts, and whether it's a happy parabola, so concave up, or concave down, whether it's a sad parabola. Those two things are very, very important. So what I'm going to do is start by completing the square because I want to find where the vertex is. So, see, remember the completing the square method, guys? B divided by 2 squared. That's what I'm going to be applying. So in this case, b is the number in front of x. Negative 2 divided by 2 is negative 1, and then square it becomes positive 1. That's why I'm adding 1 here. Now I'm just going to subtract it back because we can't just randomly add something to a number, right? So I'm going to add 1 and minus 1 it back. I'm going to subtract it back just to make sure that I haven't manipulated the question. And then we have a negative 3 at the end, so I'm going to stick that at the end as well. So guys, tell me, because we've now completed the square, we can factorize that as a perfect square, can't we? So what does that become? That should become x minus 1, the whole thing squared. You guys should be good at this. If you've forgotten this, I want you to go back to our completing the squares. So now, negative 1 minus 3 is negative 4, so that's what I have there. So as you can see, this indicates to us where the vertex is. Remember when we minus 1 from x, we're shifting to the right. And when we're minusing 4 to the whole thing, we're going down. So the vertex is positive 1 minus 4. Because we're going right in the positive direction, it's positive 1 for the x, and we're shifting down, so it's negative 4 for y. So that's where the vertex is. I'm just going to plot it there. And then now let's find our x-intercepts. Now this x squared minus 2x minus 3, we can factorize that like this, can't we? Everyone should be good at this factorization. So guys, if I let it be equal to 0, because to find the x-intercepts, I need to let y equals to 0, don't we? So I just made y equals to 0, so this whole thing becomes 0. So we can say that x is negative 1 and positive 3. And the y coordinates are always going to be 0 for the x-intercepts. So let's plot them in. Negative 1 and positive 3. And then now we can just sketch the graph of y by joining those points, just like this. Now guys, as I said, you don't necessarily have to find where the vertex is. I just did it for the sake of checking that the vertex is below the graph or above the graph. I just wanted to know where it locates. So if you have enough time, it's a good idea to draw a vertex like I did here. But I mean, if the question is just like a 1-mark question or a 2-mark question, just draw it really briefly, and all you need to know is where the x-intercepts are and whether it's happy or sad. That's all you really need to know. So don't put too much attention on drawing the graph perfectly with everything labeled. That's not really the case for this one. So, but I just did it anyway, just to show you what it looks like. And then look at the question, guys. We want to know when y is greater than 0. Y equals to 0 is the x-axis, isn't it? If it's greater, we want to know where it's above the x-axis, so it's there. And because it's just greater than 0, not including 0, I've made these circles hollow. Okay? Now again, you don't have to do that in the graph because they don't ask you to draw a graph. If they do ask you to draw a graph, make sure you do that. But if they don't, you can just draw it really briefly. So, let's find the x values because it's solving for x, isn't it? Now this yellow part of the graph, the x values that represent that part are all of these all of this part. All these parts that's less than negative 1. And this yellow part of the graph, the x values are all of these ones on the right of 3. Can you see that, guys? So we can see that x is, for this part, less than 1, and this part, x is greater than 3. And we don't put those bars there because it's not including, it's just greater than. And that's the answers. So the actual solutions are just this one, and we can find that really easily by looking at the diagram that we've just drawn up. Now, if it was an exam condition and I only have like 1 minute left, I wouldn't worry, as I keep saying, don't worry too much about drawing the graph perfectly. So I would probably go like that, just to show my x-axes. And I found that the x-intercepts are negative 1 and 3, so I just plot them. And then just draw a really brief parabola. I know that it's going to be concave up because x squared, it has a positive coefficient. So it's going to be like this. If it's greater than, it's these parts, isn't it? So then I just notify what these values represent, which leads to this as well. So again, this graph is fine enough. So you don't have to worry about, again, as I keep saying, making a perfect diagram. Okay, so hopefully that kind of makes you understand what we're doing, because we're going to move on to another question. Question 2. Solve, okay, again, it's a very similar question, but this time we're doing where it's greater than or equal to 0. So again, guys, I'm going to start by finding the vertex by completing the square. But again, guys, you can just neglect this step. I'm just doing it just to show where it locates. So I've just completed the square again. B is the coefficient of x, 2. So 2 divided by 2 is 1, and then 1 squared is 1. So I'm adding 1 and subtracting it back. And then this part of the graph, this part of the expression, we can make that a perfect square. So it's x plus 1, the whole thing squared. And then minus 1 minus 3 is minus 4. if we're adding 1 to x, we're shifting to the left, aren't we? So it's going to be -1 for the vertex, the x-coordinate of the vertex. And we're minusing 4, so we're shifting down, so it's -4 for the y-coordinate of the vertex. So let's put that there. I'm just going to plot it. And now, guys, I'm going to factorize to find the x-intercepts. So I've just factorized this one using my quadratic skills, and I'm going to let it be equal to 0 because that's what I do to find the x-intercepts. So solve it, guys. X should be +1 and -3, and make sure the y-coordinates are always going to be 0 for the x-intercepts. So just plot them, -3 and +1, and let's sketch the graph of y. All we need to do for this part is just join the points, just like that. And this time, guys, we're looking for where the graph is greater than or equal to 0. So it's above the x-axis. So these parts there, so I've just shaded them yellow. And you can see that these points here, I've also colored them in because it's greater or equal to 0. So those points are also part of the solution. Now, this yellow part, the x values that represent this yellow part are all of these ones here. All of these ones that are on the left of -3. And this yellow part, these are the x values that represent it. This is this part where it's all on the right of the +1. So the solutions are going to be x is less than or equal to -3, so -3 or less, so we include the bar. And this part is where x is greater than or equal to 1, so greater than or equal to 1. Those are the two solutions that we have. We have two distinct separate inequalities as our solutions. Okay, can you see that, guys? It's very, very similar to the previous question, and all the questions you can find that they are very similar. It just requires this process. Question 3. Okay, a similar one again. Let's go ahead and do our usual step. Now this one I can factorize immediately without having to complete the square because it's already in a perfect square form. So I can factorize it like this, x minus 2, the whole thing squared. So the vertex is going to be just +2, 0. See how we're minusing 2, which means we're shifting to the right, so it's +2, and then there's nothing added or subtracted, so it's going to stay at 0 for y. So the vertex is 2, 0, I'm just going to plot it. So as soon as you find something, just plot it and we'll at the end join it up. Now, let's find the x-intercept. So I let this one, sketch the graph of y. If I let this one be equal to 0, just to find the y-intercept, you can see that it's 2 again. So the vertex is the only x-intercept. Okay, so it's just going to be touching like this, isn't it? It's going to be just touching the x-axis at that point too. Now, if I want to sketch the graph, I have to determine first of all whether it's going to be a concave up graph or a concave down graph. But as I said, guys, the coefficient of x squared is what you concentrate on. The coefficient of x squared is a +1, isn't it? So it's a positive graph, so we concave up. Okay? Now, it's greater or equal to 0, so it must be greater than the x-axis. So it's going to be this whole yellow part there, because it's greater or equal to 0, so it's including that point onwards. So it's the whole graph, isn't it? So all the x values that represent that whole graph are all the x values on the x-axis. So basically, all real x is our solution. All values will make this happen. So that was a unique one, but it's very, very commonly asked in questions in school exams, so make sure you know what this one implies. Okay, question 4. This time, again, it's very, very similar, but this time it's just greater than 0. So again, we can factorize it as a complete square because it's already in that form. So the vertex is again +2, 0, like the previous question. It's exactly the same, so I plot it. And then now I just need to determine, because the vertex is there, that's going to be my x-intercept. So now I just need to decide if it's positive concavity or negative concavity. Now again, it's the exact same one. X squared has a positive coefficient, so it's going to be, when I sketch the graph of y, it's going to be a positive concave up graph. Now, it's greater than 0, but not including 0, so we sketch the whole thing, so we color the top part, because that part is all above 0, but we exclude this one. So see how I made that hollow? It's because we're not including 0. So anything on 0, we don't include. So how should we write the answers or the solutions for this particular case? Well, all this yellow part is all the part that's on the left of 2, and this yellow part is all the values of x that's on the right of 2. So positive of 2 and negative of 2. So we can see that x is less than 2, so 2 or less, not 2, not including 2, so I don't put the bar there. And this part is where it's greater than 2, again not including 2. So in this section, although it's exactly the same as the previous question, because we don't include that point 0, we'll have to put in 2 solutions, 2 distinct solutions. One's where it's less than 2, one's where it's greater than 2. That's the solution, guys. Can you see it? So all real x, but x can't be equal to 2. That's another way you can put it. So this is also fine, or this is also fine too. You can say all values, but we exclude x equals to 2. So those two are 2 different ways of writing the solution. Alright, question 5. Now, this time we have a negative in front of our x squared, don't we? So the x squared has a coefficient that's negative. Now, I'll show you a trick, guys. Because the negative, that's the first thing you can kind of see. We know that it's going to be a sad face parabola. It's going to be concave down. Just keep that in mind, okay? Now, when I factorize this, I don't like having negatives in front of my x squared. So I'm going to firstly factorize by a negative. So we'll have x squared minus 4x, so the positive now becomes a negative, and the negative 3 becomes a positive 3. Okay, this is the first thing I want you to do if you see a negative in front of your x squared. Now let's do the same thing for the inside the brackets. I'm going to factorize it, just because I want to find my x-intercepts. And I'm going to let it be equal to 0, because when we find the x-intercept, we let y equals to 0. So guys, tell me, what are the x-intercepts? It's going to be positive 1 and positive 3, isn't it? So plot it in. Now, let's sketch the graph of y. Now we know that it's going to be, as I said, concave down. So I draw it like a sad face, a sad mouth. So that's what it's going to look like. Now look at the question, guys. It says y is greater than 0. Greater than 0 where it's above the x-axis. So those parts only. This part is the only part that's above the x-axis. But as you can see, guys, I've left this part hollow because we're not including 0. So we don't have a bar there, so make sure you know that we don't include those points that are on the x-axis. So guys, tell me, what are these parts, what are the x values that represent this yellow part of the graph? Well, the x values are all of these x values, isn't it? So all of this part that's between 1 and 3. So this part, any point on this part is greater than 1, but less than 3. But remember, guys, not including 1 and 3. So our solution will be x is greater than 1, but less than 3. We can put it as one whole grouped solution like that. Okay, if it's in between 2 points. Now the key part to this question is to identify that it's going to be concave down. It's very, very important. Okay, question 6. We're going to this time have where this one is less than or equal to 0. Now guys, I can kind of see here that we can't actually factorize it. It's not going to be a clean factorization. So unfortunately, guys, you might have to use some additional methods. Quadratic formula, I know you don't like using that one, but we'll still try it. So that's what we have. I'm going to use my quadratic formula like this. So minus b. b is minus 4, so I have minus 4. Plus or minus square root of b squared, so minus 4 squared, minus 4 times, minus times 4ac. So 4a is the coefficient of x squared, which is 1, and c is again the constant, which is 1 as well, over 2a. a is 1. So guys, I'm trusting you that you've all memorized your quadratic formula, so this stuff is just a little bit of revision, so hopefully no one's blank of what I'm doing here. So let's simplify it. Simplify very, very carefully, and you should get something like this. The negative becomes a positive, and negative 4 squared is 16. And 4 times 1 times 1 is just 4. So 16 minus 4 is 12. And 2 times 1 is 2. I've just simplified it like that. And I can simplify it further because the thirds, I can break it down. 12 is 2 root 3, isn't it? Root 12, we can simplify it down to 2 root 3, right, guys? We've done this before. And 2, 4, and 2. 2 is a common factor. So I can make that 1, make that 1, and that becomes a 2. I'm just dividing everything by 2, which is the common factor. So I have 2 plus or minus root 3 left. So make sure you simplify it down as much as possible when you're using this. So x is going to be something like this. So we have 2 minus root 3 there, and 2 plus root 3 here. So those are the two distinct x-intercepts. And because x squared has a positive coefficient, we know that it's going to be concave up like that. Now, I've shaded in this part because it's where it's less than or equal to 0. And you can see that I've made this also colored in. So these parts are also part of the graph because it's equal to, less than or equal to. So guys, tell me, the x values that represent this part are all of these parts in between, isn't it? So this part. So these parts is where it's greater than this point, but less than this point. So we can write it like this. X is greater than or equal to 2 minus root 3, but it's less than or equal to 2 plus root 3. Make sure you have those bars because we're going to be including those points that are on 0. So that was a bit more tedious because the only reason is because we use the quadratic formula and it gets a bit annoying. But yeah, take extra care there, guys. That's very, very important. You be careful. Alright, this one, we have where y is greater than 0. So again, guys, I'm going to use my completing the square method. So, well, what I'm going to do is I know that b is negative 4. So b divided by 2 squared, right? That's what we do for completing the square. b, which is negative 4, divided by 2 is negative 2. Squared is positive 4. So what I'll do is the 5, I'll just make it 4 plus 1, kind of separate it out. So now I know that this is going to be a complete square because that's b divided by 2 squared. So that's going to be x minus 2 squared plus 1. So the vertex is going to be positive 2 plus 1, yeah? Like that. But again, guys, you don't necessarily have to find the vertex if you know where the x-intercepts are, but I'm just going to show you here that the vertex is located here. Now, guys, look at this. X squared is a positive coefficient, so it must be concave up. Now, the only way to make this concave up is for the graph to look like that. So, even before we attempt to find the x-intercepts, we know that there won't be any x-intercepts because the only way this is concave up is where it's above the vertex. So we don't have any x-intercepts. That's why I wanted to find the vertex first. So the graph kind of says, the question asks us to find where y is greater than 0. Now 0 is here, the x-axis. The whole graph is above 0, clearly, isn't it? So the x values that represent this part of the graph are everything on the x-axis, so we can say all real x. That's the solution, the whole thing, without any doubt, because I'm 100% sure that the graph is completely above y equals to 0. It's going to be all solutions, all real x. Now we'll try another one. We've got x squared plus 4x plus 5 is less than 0. So this time, again, I'm going to use my completing the square method, and I know that b divided by 2 squared is positive 4. 4 divided by 2 squared is 4. So because 4 is part of 5, I'm going to separate 5 like this, 4 plus 1 like that. So this part here, guys, is a complete square where it's x plus 2, the whole thing squared, and then plus 1. So guys, tell me what the vertex is going to be. Because it's plus 2, we're going to move to the left. So it's going to be minus 2 for the x-coordinate, and plus 1 means we shift up, so it's positive 1 for the y-coordinate. So plot it in. Now, again, guys, check. The coefficient of x squared is positive, so again, it must be concave up like the previous question. And the only way for it to be concave up is for it to be greater than the vertex. It's to be vertex onwards, isn't it? So again, before we even attempt to find the x-intercepts, I know that it's going to be looking like this, so there's no x-intercepts here. Now, the question asks us to find where y is less than 0. Now remember, y equals to 0 is the x-axis, and less than 0 means it's below the x-axis. But is there any part of the graph that's below the x-axis, guys? No. We know that perfectly the graph is completely above y equals to 0, the x-axis. There's nothing below. We can't see anything So therefore, this one is a no solutions. So it's kind of like the opposite of the solution of what we got in question 7, isn't it? No solutions, because we can clearly see it from the graph. So that's the answer, guys. Alright, these questions is again a very, very common exam style question. So make sure you understand how this is all being brought about. Now guys, the key part was to draw the graph, wasn't it? So always draw a graph first and then identify the solutions.